Well, all right, ladies and gentlemen, if you take a look at the word problem. So for number 13, Tara's car travels about 25 miles on 1 gallon of gas. She has between 10 and 12 gallons of gas in the tank. List the independent and dependent quantities or variables. So does anybody remember the independent variable? Would that be the x or the y? Virginia? The x. So what would the x represent in our problem? Yeah, so the x value is the independent, and that would represent the number of gallons that are in our gas tank. So then Virginia, y would be, and that's right. So that would be our total distance. So the distance that you travel depends on how much gas you have in your gas tank. So the more gas, the further you can travel. The second question, so that would be A here. So B says find a reasonable domain and range for the information. So if the information that says we have between 10 and 12 gallons of gas in the gas tank, domain are all of your x values. So thinking about what it means to travel, have gallons of gas in your gas tank, what would the domain be? Virginia?
In brackets, 10, 12.
So that would be the upper side, but we're traveling, and like it's not you might have 12 gallons of gas, but you don't always have 12 gallons of gas because if you drive, you're not going to have 12 gallons of gas after you drive so many miles. So what would the least number of gallons of gas if you're traveling and you're driving around? What would the least number be? 0. So if you have this upper number, if you have 10, 11, or 12, that's fine. Because it says it's between 10 and 12. We'll say that there's 12 in there. So what would go around those two values for the domain? Can I have 0 gallons in my gas tank? Yes, technically you can. I mean, you're not going to go anywhere, but it could happen. You could run out of gas and be stranded on the highway, like my father did when we were traveling home from Florida, and I was 10. And it was the middle of the night, because, I mean, why wouldn't it be?
You sound so traumatized about that one.
I am. I mean, that's years later. It was horrible.
When I was 10.
When I was 10. Because I told him that we were going to run out of gas.
And you're
Oh,
like,
dang,
No, Miss Kane, that won't happen.
He was like,
no, Miss Kane.
we can definitely go another,
Silly Mrs.
like, 50 miles. Yeah.
You're not. Your restaurant is Miss Kane.
Yep, definitely. I'm like, no, leave me alone. We're just driving. You silly little.
You silly little
All right, so if my domain would be the gallons of gas in the tank, which would be from 0 to 12, assuming that we've got 12 in there. Again, if you had an 11 or a 10 there, that's okay as well. But if I drive the car and I run out of gas, then I wouldn't have anything left. What would the mileage be then that we would have that corresponds with that, Sarah? Right, so it would be 0 to 300. 0 because when you fill up, you currently didn't drive anywhere. Like you're at the gas station, you have not driven any miles yet. Once you start driving on that new gas tank, then it would increase. How'd you get the 300? Yeah, so it said 25 miles per gallon. So if you multiply 25 by 12, you get the 300. So that would be the domain and the range based off of this situation. The last part says to rate them as inequalities. When you're rating them as inequalities, you're just taking the fact that it has a bracket. So I would start with my 0. A bracket means less than or equal to. So the equal to is the bracket. And then we have an x, and then less than or equal to 12. So your inequalities always face the same way. You start with the smaller number, you go to the larger number, and then it's either a less than or equal to, depending on if you have a bracket or a parenthesis. So the range would be 0, less than or equal to y, less than or equal to 300. Any questions with that one? or like what you're thinking about when you're going through the problem?
Like, I had it 10, 12. Like, why is it 0 instead of how much she has at the moment? Because it would be if she has between that, you would do it that.
But you're not always, like, I mean, you only have that amount when you're sitting and filling it up. Like, once you start traveling, which is what you're going to do with the car, the domain are all of the X values that pertain to the problem. So it's not just that one. You're always going to have 10 gallons of gas. Aaron, I'm sorry. Anthony. Yeah. Any other questions? Okay, so if you look at B, I'm going to rearrange this part here. So number 14 is a little different. Sal and 3 friends plan to bowl 1 or 2 games each. Each game costs $2.50. List the independent and the dependent quantities. So what would the X be for this problem? Ethan? So X would be our number of games, and Ethan, the Y would be the cost, right? How much it costs us to bowl. So this one's slightly different than the previous one. So the domain are the number of games. So Ethan, if we each bowl 1 or 2 games, what does that mean then? How many games are we bowling? 4 or 8. Is there anything in between there? No. Because all of us are either bowling 1 game together or all of us are bowling 2 games together. There's no option for me to bowl 1 and my other 3 friends to bowl 2. So in this case, it's just those 2 numbers. I can't bowl a game and a half, I can't bowl a game and a quarter, I can't bowl a game and a 10. I mean, I guess technically you could, and then you like, just half, so you still have to pay for the full game. So it's either 4, because all of us are bowling a game each, so there will be 4 games being paid, or we're each bowling 2, so that really means that we're all paying for 8 games. So then the range would have to correspond with the domain. So what would the range be? What's the total cost? Ethan?
$10.
Yeah, it's either going to cost us $10 or $20. So it's one or the other. Again, it's nothing in between. So that would be the difference from A versus B. So if you're driving, you are driving a 1/10 of a mile, a 100th of a mile. Whereas if you're bowling a game, you're either bowling the whole game, you're paying for the whole game, or you are not. So it's one or the other there. For part C, you can't write it in interval, or I'm sorry, as an inequality. So there is no inequality to write because there are no numbers that exist between those values. It's either going to cost you 10 or 20 bucks. It's not going to cost you 15. It's not going to cost you 13. It's just one or the other. So you cannot do part C. Any questions with the 2-word problems? It's kind of like the thought process for those word problems.
Where did the 4 and 8 come from?
Because you and 3 friends are each bowling a game. So really, we're paying for 4 games, we're paying for 8 games. So 4 of us are going bowling, so I'm either paying for 4 games or paying for 8. Other questions? So we are going to finish the notes in the small little domain and range packet today. We're going to rely on the calculator to get a couple of graphs to look at instead of the graph being given to you. Tomorrow we'll start back into the regular packet and start looking at functions and combining functions together along with analyzing the domain and range. So if you could take out that little packet. So the little packet from Friday. So the question at the top of the page, how do you determine the domain of a function without using the graph? That's going to be our goal. So after we look at 4 graphs and try and make some summaries, is there a way for us just to use the equation without graphing a function to decide what the domain is? And it only works for, you play basketball, right?
Yeah.
You're just better on the court, okay?
He's better on the bench.
Oh!
I don't like that he sits right behind me.
He might leave you some nice things in your hair later on.
What's my hair?
I didn't touch it.
So we're going to see if we can try and determine what's going on with the domain range after analyzing some graphs. So with your calculator, if you go to y equals, the square root button is second x squared. And when you enter this into the calculator, I think it depends on like the version of your calculator. Make sure that your like the radical part grows with the equation that you're putting in. I can't remember what it is. X minus 2. So if you look, like you want to make sure that that little bar is underneath both the x and, or above both the x and the minus 2. So if not, you'll have to put it in parentheses, and it just depends on what calculator you have. And then you can hit graph. And you'll see we have this little like arch that's arching to the right side of the screen. You might need to hit zoom 6 maybe.
X min is 100.
Yeah, just do zoom 6.
Okay. Does that reset?
It just resets just like with your whole calculator, just like graph. Question.
What do you mean that? You're not gonna do that. What do you mean that? There's no name. There we go.
Alright, so we're going to graph this. If you go to your table of values, so that's just second graph. Why would there be all those errors?
Oh, I don't have errors.
Oh, you don't have errors?
Oh, wait, yeah, I do. I was just kidding.
Kate, why would there be errors?
1, 2, 3.
Yeah, you can't have the square root of negative numbers. So I have more errors than you have probably. But you can't have the square root of negative numbers. That's why it says error. So make sure you plot a couple of points. Maybe like 3 is enough. But at 2, 0, that's the first point that it doesn't have an error next to. And then I have a point at 3, 1, and 6, 2. So I need my starting point at 2, 0. And then I had 3, 1, and 6, 2. And then kind of make a little arch for your graph. Would you like to borrow one?
Yes.
They're both old, so they work. I'm just gonna have to. It's not as fancy as yours. What would the domain of this graph be? So we're just looking at the domain. What would the domain of the graph be? So think left to right. David? Okay, so I agree with, and this would be a bracket, right? So the 2 gets a bracket because there is a point when x is 2. That's the starting point of the graph. Parenthesis around the infinity because we don't know what point that value is. We don't know where infinity goes to. Alright, so let's look at the next one. Go back to your graph, y equals. So this one said -2 and then the square root, not the square. And it was x plus 3. Ethan, you're going to have to put parentheses around whatever's underneath your radical. Because it doesn't draw the little radical for you. And then again, hit graph. So because of the negative sign, it flips this graph upside down. So remember when we were talking about graphs, a negative makes it go down, a positive makes it go up. It has the same stuff happening with these graphs, and we will learn how to graph them by the end of the chapter. But if you go to your table of values, just to get a couple of points. So I have a point at 1 and -4. -3, 0, -2, -2. So again, I'm just pulling numbers from the table of values right now. What would this domain be? David? X values. So how far? Positive infinity, right? So both of them are going to the right, so that's why they both go to positive infinity instead of one going to positive versus one going to negative infinity. Question. Does anybody notice like what in the equation kind of correlates with the graph?
The number underneath the square root.
Yeah, the number underneath the square root. What happens if we plug a -3 in there?
It moves to the left by 3.
Yes, it moves that left by 3. So that number underneath the square root, when we were talking about parabolas, remember we said it moves the opposite direction when we were in that vertex form. So that x minus 2, even though there's a -2, it's really moving the graph the other direction. Questions? Virginia?
My graph, when I look at it, the graph, it doesn't connect to the line.
You know what, it just depends on the version of the calculator. So in some graphs it'll make it connect and some it will not. But it is allowed to be 0. Because I can take the square root of 0. And if you check it out in your, like you should see that at -3, 0, it does touch. But for some reason, like mine connects, but it just, some do not. I don't know why. Yours calculator is way more than mine. Alright, so then if you look at the third and fourth problem, so these two problems both had square roots, so there's something special happening with square roots. The next two problems are both fractions. Now when you put a fraction in your calculator, if there are more than one term, which multiple terms in the denominator or the numerator, you need to make sure you're putting parentheses around that. If you don't, then it's only dividing by whatever's next to the division bar. So we need to put parentheses around any quantity that would be in a fraction, numerator, denominator. So going to the y equals, this first one just says 1 divided by, and then you need to put parentheses with the x plus 5. Or is it x minus 5? Minus? So that it knows you're dividing with the x minus 5 and not just the x, not just whatever's next to the division. This one's a little crazier. So we have these two lines, curves actually, one on the left, one on the right. Minus, so x minus 5. When you go to your table of values, if you arrow when it gets closer to 5, it says error. So, bless you. The other graphs had errors when it was on the negative side. This one says error at 5. If you look at your equation, why would it say error at the number 5? Tyler?
Because if you plug it in, it will be 5 minus 5, which is 0. You can't divide by 0.
Right. So if we had a value of 5, and I plug 5 into the equation, 5 minus 5 is 0. Well, we're not allowed to divide anything by 0. That number doesn't exist. So that's why there's the word error next to that in the graph. So on your graph, at the value of 5, that's right here, it never touches that. It kind of just skims vertically next to it. So looking at your picture, and you can rely on your table of values if you want, but looking at your picture here, it's going to skim really close to 5, but it's not allowed to be it because then it creates a 0 in the denominator. So I have these two pieces, two curves, but they don't touch 5, because if it touched 5, then I'd have a 0 on the bottom of the fraction. So this domain is a little different. Anyone want to try and take a shot at the domain? Virginia?
And a bracket, no, in parentheses, infinity, to 5 in parentheses, and then parentheses 5 to infinity.
Nice
Oh, wait,
job.
the first one's negative though.
Yeah, I got the negative. So the first one, the one on the bottom left. So this goes to negative infinity. It's going to go on forever and ever to the left. It's coming along, and then at 5, it just stops and it goes down. It will never be 5, which is why we have to have a parenthesis around the 5. It's not allowed to equal 5. The other piece starts at just past 5, so that's why there's a parenthesis around it, and then it goes forever to positive infinity. So because there are two pieces, we need to describe each piece. Neither of them can have a bracket with 5 because the problem's never allowed to have an answer of 5. Questions? So why don't you graph that last one? We have 2x minus 1 on the top, 2x plus 4 on the bottom. Again, put parentheses around that. Numerator and denominator this time. We have to make sure the calculator knows to group it all together. So 2x minus 1, 2x plus 4. So you might visually be able to see like that number, they're kind of like splitting apart. But if not, and you're not sure what the number is where the error exists, just kind of look in your calculator. So at -2, it says there's an error in the calculator. That means if we plugged a -2 in for x, I'd get 0. So that's why that value is there. So really that's saying my x is not allowed to be whatever number makes it equal to 0. It's not allowed to be -2 because that's what makes it 0. So here's the graph that we're looking at. Anyone want to take a shot at the domain? Caitlin, what do you think?
Parentheses, negative infinity to -2.
Good.
Then parentheses, -2,
Nice job. So if you want to flip to the top of the next page then, this is Kane. Mm-hmm. Okay. Bye. Timmy, you have an early dismissal and classes at the attendance office. All right, so if we look at the top of the page, we're going to try and summarize those two things. So when we're talking about domain, it says it excludes values that. So the first two dealt with square roots. What numbers weren't we allowed to have underneath the square root? H? Yeah, so domain has to exclude the values that make this square root negative. So that means whatever's underneath this square root, that has to be greater than or equal to 0. Because it can't have numbers that are negative. Well, if it's not negative, then it has to be positive, which means it could be greater than or equal to 0. So whatever's underneath here has to be greater than or equal to 0. When we were talking about the fractions, what was happening with the fractions? What would the domain exclude? So what values would the domain exclude when we're talking about fractions? Virginia?
5 would make the denominator 0.
Yeah. So anything that made the denominator equal to 0, whatever's down here, it's not allowed to equal 0. So if it makes the denominator 0, then we have to exclude it from our domain. Questions? 3 other things about domain, and these are domain of common functions. So if you have a square root function, it has to be greater than or equal to 0, whatever's underneath the square root. If we have a fraction as a function, then whatever's in the denominator isn't allowed to be 0. However, there are other functions that we've looked at, and these common functions would be like the even versus odd. Here we go. So if we have an even degree polynomial, remember that was like the x squared, x to the 4th, x to the 6th. This is what those polynomials would look like. Even degree means both go up or both go down. That was an even degree polynomial. Every domain for any even degree polynomial is always negative infinity to positive infinity. Because it's going to continue to get wider and wider and wider, and it doesn't ever stop. Our odd degree polynomials, that's the one that split. So the 1/2 went up, the other half went down. Something like this. Its domain, x cubed, x to the 5th, x to the 7th, also was negative infinity to positive infinity. Because again, it's going to just continue to stretch wider and wider and wider, stretching left and right, and it doesn't ever stop. So any even or odd degree polynomial, as long as it has a power that's even or odd, it'll always have a domain of negative infinity to positive infinity. The last one here, absolute value function, we briefly talked about on Friday. Does anybody remember what that graph looked like, Kate? Yeah, that was the V. Kate, what would the domain of an absolute value graph be? Yep, negative infinity to positive infinity. So this page, the goal is for us to look at an equation and not plug it in the calculator. And this page is a page of notes for you to look at the equation and say, this is what my equation is, what does it match up with, and then that's what kind of tells us the domain of the graph. Not the range. So the range, we'd always have to look at the graph, but the domain, we can rely on the equation. So I believe there are a couple examples underneath. All we're asked to do is look at the equation and decide what the domain would be, writing it in interval notation. So the first one is a fraction. What has to happen in the denominator of a fraction? Page? It can't equal 0. So in this case then, Paige, x can't equal -6. So it's not allowed to equal 0. Whatever number makes it equal 0, it can't be in the domain. So Paige, can you correlate that to write it in interval notation then?
I said negative infinity, comma, -6 in parentheses, and then -6 to positive.
Okay. So whatever number it can't be creates 2 parentheses, one for the left, one for the right side of the graph. So when you have a fraction, your answer, your domain will have 2 parentheses. The next one, we have 3x squared minus x minus 4. What type of function is this? Look at the largest degree. What kind of function is it? Aaron?
Even degree polynomial.
Yeah, this is an even degree polynomial. So Aaron, what's the domain of every even degree polynomial?
Negative infinity to positive infinity.
Negative infinity to positive infinity. That's it. So the fact that it's an even degree, the largest degree up there, the largest exponent, 3x squared. Number 3, we have a square root, and then underneath is 2x minus 5. So when we have a square root, whatever's underneath the square root has to be greater than or equal to 0. It's allowed to be 0 because the square root of 0 is 0, but it cannot be less than 0. So if we solve this little equation, that tells us what x has to be bigger than. So what does x have to be bigger than if we solve the equation? Should you? Greater than or equal to 2.5. So how would we convert that to interval notation? Right. So greater than or equal to means it starts at 2.5, which gets a bracket. It goes to positive infinity. There are 3 more underneath. See if you can do those 3 more problems that are underneath. So this one is an absolute value. Kate, what did we say about the graph of an absolute value? Its domain is negative infinity to positive infinity. Every absolute value graph. Number 5 is a fraction. So, what's going on with the fraction? So close. About not equal to 0. So it's not allowed to equal 0. So what does that mean? X isn't allowed to be. So add 7, divide by 2. So that means negative infinity to positive 3.5 with parentheses. 3.5 to positive infinity with parentheses. Is that what kind of function is the last one?
The last one, I'm not sure,
What's the largest power?
is to the cube.
And is that even or odd?
That's odd.
So
that
what-
would be negative infinity positive.
Exactly, negative infinity to positive infinity. So the homework that you'll have, the first half of this worksheet, the graphs are already given to you. You'll be getting the domain and the range, so like Fridays. The back, you're looking at the equation and then just finding the domain based off of the equation. Do not graph that. So use the equation, use that page in your notes to calculate or figure out, determine what the domain would be.
Oh, yeah.
Maybe this is we haven't
You might don't. What? I did.